So we're now ready to talk about some of the key combining operators in the Flux class. And you'll see here that we're going to talk about three of them. They're three of the most important operators. They're going to be reduce, collect, list, and collect. And these all have variation equivalents in Java streams. So some of this discussion should sound a little familiar if you're familiar with Java streams. So we'll start by talking about the reduce operator. And in fact, you get a chance to use the reduce operator in the context of the of Java streams in assignment 2B. This set, of course, is not the Flux version because we're not using the reactor mechanisms. We're using streams, but you'll get a chance to play around with reduce nonetheless. So what reduce does is it reduces the values from a Flux sequence into a single object of the same type as the emitted items. And this reduction is performed by using a bifunction parameter. And remember, a bifunction takes two parameters and returns a result. Now, this method is very interesting, and the way it works is this parameter is passed repeatedly to the intermediate result of a reduction and the current value. So here we have an example where we've got a use of reduce on a flux of integers. And just to make it a simple example that I can talk about in a handful of slides, we'll say that we've got a flux of integers with the values 1, 2, 3, 4. And what we're going to do is we're going to go ahead and reduce them by adding the values together. We're going to sum the results of that string. So it starts out where we give an initial value of 0, which is the default for the reduce operator. And then we take the first flux and we add 0 to the first result in the flux sequence. We get 1, of course. And then we take that value and we feed that to the next item that's in the sequence. So now it's 1 plus 2, which is 3. We get 3. We then take that value, we feed that in to the next element that's emitted from the flux sequence. So it's 3 plus 3, which is 6. And then we go ahead and take that value. We take the value 4 and we add 6 to 4 to get 10. So of course the sum of 1, 2, 3, 4 is 10. And this is illustrating how the bifunction is used to take successive pairs of values, apply some operation, and then update the running result. The result of all this is a reduced flux, and it's emitted from the final call to that bifunction process as the sole item of a mono. So we end up reducing things into a mono, which of course is, as you may recall from earlier discussions, a single value. Now, if the flux is empty, then we'll get back an empty mono. It won't have anything to be emitted at all. And if there's cancellation or if an error occurs, then this running tally, this accumulated value, is discarded upon cancellation or upon error. Now, something important to remember here. Reduce only works if the upstream in the flux, something up the chain, ultimately generates the on complete signal. If you never get for example, if you're going to multiply a bunch of things together, perhaps using the flat map concurrency idiom as we're showing here, then you want to reduce the results to a single result. That all works fine. However, if you have an infinite number of items, which we don't have here, but if you were to have that, then the operator will never get called because it expects an on-complete signal before it will wrap up. And if you try to do this, you're likely to eventually run out of memory. So you'll get the dreaded out of memory error, which is an exception that's very, very problematic because it means you've run out of memory in your program. RxJava also has a reduce operator that works the same way. Likewise, there's several reduce operators that are so-called terminal operators in Java streams, and they work much the same way. The main difference is that they have a few differences in terms of the values you can pass. You can give them initial seed values, for example, that are different from 0. let's turn our attention now to the collectList operator. This is a very handy convenience combining operator that collects all the elements that are emitted by a flux into a list and returns it as a mono to the list. So you get back a mono that will emit the list that has all the values that came out of the flux. So this is a very useful operator if you want to convert from the reactive world to the non-reactive world. So the world of fluxes to the world of lists. And the list itself will be emitted by the mono when everything is done. So here's a simple example that we'll look at in our case study, where we're going to iterate through a bunch of big fractions. We do some operations to each one. We filter out stuff that's going to be 0 or less than 0. And then we go ahead and collect all the results into a list or to a mono to a list. RxJava doesn't have a collect list method. Instead, it has a collect method, as does Project Reactor. We're about to talk about Project Reactor's collect. And you'll see that collect followed by toList gives essentially the same behavior as collect list. And that's true for both RxJava and true for Project Reactor. And of course, Java Streams has a collect method that can be used with a list as well. In fact, we can use the toList method to work like collectList does in the Project Reactor API. So the third and final combining operator we're going to talk about is the collect operator. And this collects all the elements that are emitted by the flux into a so-called mutable result container. And the parameter, it's actually basically borrows the same types that exist with Java Streams. So the Java Streams interface has a collector, and that same collector is used here with Flux. So remember, the collector defines a bunch of factor methods like supplier, accumulator, combiner, finisher, and so on. And same thing is true in RxJava and Project Reactor. The collected result is emitted into a mono, and that, again, like collectList, will be able to provide a value when everything completes successfully. Now, one of the things you can do with collect, you can do many things with collect, but one of the things you can do with collect is you can use it to seamlessly integrate Project Reactor and Java Streams capabilities. So here's an example where we have Project Reactor being used to wait for a bunch of asynchronous operations to complete, and then we are going to collect it into a list, and then we can use that with Java Streams. So it's pretty cool. RxJava can do the same thing. And of course, Java Streams also has a collect method that it can be used to collect things and collect them into sets or maps or lists or whatever you want to collect them into arrays, for example. So that's the end of the key combining operators in the Flux class. And at this point, you know more than you need to know in order to do the various programming assignments that we'll be doing later in the course.